Okay, this is Mr. Vakar, and I'll be your well-rounded math teacher today. Today we're going to be talking about solving compound inequalities and absolute value inequalities. This is section 1.6 for Algebra 2. One test used to determine whether a patient is a diabetic is a glucose tolerance test. Patients start with the test in a fasting state, meaning they have had no food or no drink except for water at least 10 hours, but no more than 16 hours. Write the acceptable number of hours, H, for fasting by using an inequality. So first of all, except for at least 10 hours, they have to fast for at least 10 hours. So H has to be greater than or equal to 10. And they can't fast for more than 16 hours. So H has to be less than or equal to 16 hours. A lot of times when we work with inequalities, especially compound inequalities, we're going to work with a number line. The two numbers we're working with is 10, 11, 12, 13, 14, 15, and there's 16. It says this, H is greater than or equal to 10. So we're going to color it in. Actually, I'll make it a different color. There it is. And everything going in this direction is greater than 10. It also says, though, that H is less than or equal to 16. So both of these inequalities have to be true. Here's less than or equal to 16. And it kind of merges into this other one. So basically, you can have fasted anywhere between 10 hours and 16 hours. Here's your reasonable number that you could have for H. When you're working with an AND statement, there's two kinds of inequalities. One's an AND and one's an OR. When they're written as an intersection like this, in between 2 points, usually you don't write it using the word AND. Your final answer, you'd say, well, first of all, H is less than or equal to 16, the obvious one up here. But you'd flip this one around and read it backwards. You'd say H is greater than or equal to 10 like this. So basically, it's between 10 and 16. And the way you'd read this is 10 is less than or equal to H, and H is less than or equal to 16. Compound inequalities. What do we got here? Compound inequalities. Two inequalities joined by the word and or the word or. So, okay, and inequalities are true if and only if both inequalities are true. So in order for this compound inequality to be true, if you're working with the word and, it has to satisfy both inequalities. So looking at this one, and it's already graphed for us, but I'll look at that again in a second. X is greater than or equal to -1, and X is less than 2. X is greater than or equal to -1 right here, going in this direction. All those numbers are greater than -1, and X is less than 2. So we're just going to circle it this time. And it overlaps, intersects with this one. Now we could keep going. X is less than 2. We could keep going into this area right here, but that wouldn't be greater than or equal to -1. So all our solutions for X are in between these two numbers. So the way we would write this answer, if this is what we worked a problem down to, we'd say -1, 2, X in the middle, and obviously X is less than 2. And here's where students get troubled a little bit. It says greater than or equal to, but you're going to put less than or equal to, because you're basically flipping this inequality. When you flip this inequality and put a -1 here and an X here, you flip the inequality symbol also. So it reads, -1 is less than or equal to X, and X is less than 2. That's the inequalities with the word and, compound inequalities. This is a typical OR inequality. It can be one or the other. Inequalities are true if one or more of the inequalities is true. So these don't both have to be true. It only has to satisfy one of them to be true for the whole inequality itself. So the first part here is X is less than or equal to 1. Right here, and it keeps on going. Or X is greater than 4. And all that's saying is this. Would 0 be a solution for this compound inequality? Yes, because it satisfies the first inequality. How about 5? Yeah, because it doesn't have to satisfy the first one. It can satisfy the second one, and it does. It does satisfy x is greater than 4 right here. But would 2 be a solution for this inequality? No, no it wouldn't. So how do we write our answers when it's an or statement? Just like this. You would leave it just like that. If it's an intersection between the two, an and statement, you're going to write it like this, between the two numbers that it works for. Okay, now to get to the solving part. Solve each part of the inequality, then graph the solution, and we will do that on the number line. This is a compound inequality because there's two inequalities. We have less than and less than. Now, the question is this an and or an or statement? I don't know. Well, actually, I do know. It's an and statement, and this is why. There's two inequalities here. That's what makes it a compound inequality. But they're all written together like this. When they're all written together like this and there's no statement there, it's an and statement. The way you would do this or break this problem up, and the way you would actually read it is take the 13 is less than, what is it less than? 2x plus 7. And 2x plus 7 again is less than 17. So you break it up, you put the 2x plus 7 with both inequality, and that's your problem. So we got 13 is less than 2x plus 7, and 2x plus 7 is less than 17. Now, if we want to solve for x, we just solve both inequalities separately. So the first thing I would do right here is I want my variable term on the left-hand side. So I'm going to subtract 2x from both sides. When I do that, I get negative 2x plus 13 is less than 7. Now, I got to get my variable term by itself, so I'm going to subtract the 13. I get negative 2x is less than, because these 13s cancel out now, negative 4. Finally, get rid of the negative 2, divide both sides by negative 2. Oh, divided both sides by negative. I got to flip my inequality symbol. X is greater than 2. So that's my first solution, and that came from the first part of the inequality. The second solution here, we'll start solving. Let's get 2x by itself. So I'm going to subtract 7 from both sides. 2x is less than 10. Divide both sides by 2, and I get, I'll put it down here, x is less than 5. And we got to put the word and here because it's a intersection which involves the word and, because it's all written together like this. Now, you always graph your answers, and we'll take a look at them here on the number line. Here's 2, 3, 4, and there's 5. First of all, x is greater than 2. So I'm going to circle the 2, and I'm going to be going in the direction of the 5. X is less than 5. Well, circle the 5, and I'm going to go in this direction. This is a classic compound inequality with the word and. All my solutions are right here between, hold on a second, between 2 and 5. So I'm not going to leave my answer like this. I'm going to say, first of all, the obvious part, x is less than 5. And here's where people get stuck a little bit. Basically, you're just going to flip this around. 2, instead of greater than, you're going to say less than x. So all my solutions for x are between 2 and 5. And there's your answer. 2 is less than x, and x is less than 5. So it could be 2.1. It could be 3. It could be 4. It could be 4.5. All these answers would be solutions for this compound inequality. I'll let you guys try this one. We're going to go to the or statement. Here's a compound inequality with the word or. We don't have to split it up. It's already split up for us. Basically, we just solve both inequalities, graph it on the number line, and find out where our answers are going to lie. So x plus 5 is less than or equal to 7. Solving for x here. Subtract 5 from both sides. and I get x is less than or equal to 2. Over here, x minus 6 is greater than 2. Adding 6 to both sides, I get x is greater than 8. So, x is less than or equal to, or x is greater than 8. Graphing this on the number line. There's 2. We'll put 8 over here, that's fine. It's less than or equal to 2. Going in that direction. And it's greater than, so don't color it in, 8. Going in this direction. So basically the only numbers that are going to be your answer are between the 2 and the 8. So could 1 be a solution for this component inequality? Yes. Could 10? Definitely. What about 4? Here's 4 right here. Would that be a solution? No, 4 is not a solution. We're going to get into absolute value inequalities in the second here, but I want to talk to you a little bit about absolute value, refresh your memory here. Absolute value of a number is the distance the number is from 0 on the number line. Right there. The distance number is from 0 on the number line. So if I want to find the absolute value of 7, I want to find how far 1, 2, 3, 4, 5, 6, and it's pretty obvious how far 0 is from 7 on the number line. Well, it's 7 units, so the absolute value of 7 is 7. How about -2? Well, there's 0, 1, -2. How many units is -2 from 0 on the number line? Well, 1, 2 units. So the absolute value of -2 is 2. So basically, whenever you take the absolute value of a number, you make that number positive, even if it already is positive. It's just distance from 0 on the number line. So when you look at this problem right here, the absolute value of x is equal to 3. Well, what number could you plug in for x that would make this a true statement? Well, look at the number line here. There's 0. 1, 2, 3. 3 is 3 units away from 0 on the number line here. What other numbers? -3. Whenever you talk about distance, you talk about it as a positive length. So the absolute value of x right here, well, that actually is x could equal 3, or x could equal -3. Now what I want you guys to do is take the 2 Khan Academies I put on Schoology, and I want you to watch those tonight. I got a lot of viewing for you tonight, but this is kind of a big topic and it's hard to understand. So if you watch those 2 Khan Academies videos, and then we'll work on this some more tomorrow. Hopefully we can get everyone to understand it. Have a great evening.